This is a research of Sapienza University in Rome and University of Calabria. In this presentation, we will provide a very short overview about extreme value analysis. We will focus on the question if non-stationary can be assumed as synonymous with the term change, and then we will show the first results from the developed EXTRASTAR software. Extreme value analysis can be diversified according to the choice of probability distribution, according to the choice of a stationarity or non-stationarity approach about parameters, according to the choice of local or regional estimation depending on the sample size, and on the choice of technique for parameter estimation, for example, maximum likelihood, method of moments, less square, and so on. And choosing a specific probability distribution concerning frequency and magnitude of extreme events above a threshold, we can obtain specific probability distribution about annual maxima. And in this work, we focus on the well-known GEV distribution, in which Gumbel distribution is a particular case, and on the two-component extreme value distribution, in which we can discriminate ordinary and outliers events. And in this context, lambda are related to the mean annual frequency and theta to mean magnitude of extreme events above thresholds. While the shape parameter B for GEV and the dimensionless parameter theta star and lambda star for the two-component distribution are related to the skewness. And then Y is the reduced variation. Well, Gumbel, GEV, and two-component distribution have the same reduced variable if we consider the whole sets of events in Gumbel and GEV like the ordinary component in two-component extreme distribution. And then it could be not necessary to carry out specific calibration procedure for each distribution, but it can be only performed for Gumbel. Specifically, the obtained, for example, maximum likelihood estimate for Gumbel could be also used for GEV and two-component distribution. And then for GEV and TCEV, we could also only estimate B parameter and lambda star and theta star parameters. And because of between x and y there is a linear relationship, the sample skewness for both random variable is the same. Now, do climate change imply non-stationary models? Do non-stationary models imply climate change? Is it possible to model a changing reality with a stationary approach? Well, according to Newton's first law, without an external force, the position of a body in motion changes in time, but its velocity is unchanged. Then, according to the Newton's second law, a constant force implies a constant acceleration, but a changing velocity, and so on. And then, non-stationarity is not a synonymous with change. Change is a general notion applicable everywhere, including the real world, while stationarity and non-stationarity only regard the adopted model. Thus, stationary model can be also adopted for environmental change. Moreover, significant trends could not appear from the observer time series, as a relevant rate of outlier events occurred in the central part of the last century. Consequently, is climate changing? Yes, for sure. Are there particular situations for which the temporal change are hidden? Another important question is how to detect a trend. We could use Mann-Kendall test as suggested by World Meteorological Organization or other tests. But another important question is, are they fully informative? Well, in order to reply, we have to briefly introduce the concept of ergodicity. That is the possibility to estimate the summary statistics of a stochastic process from only one available realization, the observed series. And this is possible only if the process is assumed as stationary. And then non-stationary imply non-ergodicity. And then it is incorrect to estimate the summary statistics of a stochastic process from only one available realization. Then we need of external information, for example, output from climate models. And then Mann-Kendall test or similar test can only provide a generic indication, but we are unable to correctly quantify the trend. And moreover, data fitting appears as questionable. Concerning some numerical experiments, in this presentation we will show the result from a generation with Monte Carlo methodology of 5,000 Gumbel samples with 100 data, in which frequency is set as invariant, while a linear increase of the mean magnitude is assumed, and varying the sample size from 20 to 100, the Mann-Kendall test was applied. And then from the obtained result, we can view the change only from high initial frequencies, at least 60, 70 data, and high increases for magnitudes. And this is the situation from two different realizations from the same changing world. On the left, we have a time series in which non-stationary approach could be adopted. And then on the right side, we have a generated time series in which the stationary approach it's good. Then climate is clearly changing, but it can be difficult to detect a trend only from observed series. And then, without any external information, a stationary approach could be also suitable. And in this context, as stationarity can be considered as undead, we developed a software, an Excel file with the Visual Basic for application macros, in which in the future we will also implement the module for non-stationary approach. And this is a video tutorial in which we can select the option single time series on ensemble time series. For ensemble time series, after a specification about sample skewness, we can select from the specific common button the input file, that is a text file with two columns, sample size and sample skewness. Go to the Abacus, in which there are the confidence band of Gumbel for default, and by selecting specific option for GEV and two-component distribution in terms of B and lambda star and theta star, and then we can analyze this plot. And then concerning The second option, single time series, we can upload the input data, the chronological input data, in which then we can compute automatically sample size, sample mean, and so on, and then select stationary or non-stationary approach, maximum likelihood estimation from Gumbel, and then select the specific options for GEV and two-component distribution. We can visualize the plot, and then with Monte Carlo simulation, we can analyze also the confidence bands for each analyzed distribution. In this case, the used input file was obtained from the GEA database regarding the network of daily annual maximum rainfall series. Overall, about more than 3,000 samples with a sample size of at least 20 years were analyzed, and the mean value of the sample size is approximately 50 years. And from the obtained result, we can conclude that for about 80% of time series, modeling with the Gumbel distribution could be suitable. Modeling with the GEV with B parameter equal to minus 0.1 could be suitable, and the modeling with a two-component extreme value distribution with theta star equal to 3 and lambda star equal to 0 minus 1 could be acceptable for about 92% of time series. So it could be possible to assume a unique homogeneous region for the whole investigated territory concerning skewness analysis, and to state that TCEV with different set for lambda star, theta star of Gumbel distribution could be adopted for other isolated rain gauges. Moreover, further analysis concerning, for example, quality check of data could be necessary in order to explain or justify simple skewness less than 0, for which Gumbel distribution is not even appropriate. Conclusions. EXTRASTAR software can represent a user-friendly tool for the statistical analysis, regional or at site, for annual maxima. Then, for an observer time series of interest, it is possible to quickly test the modeling capability for Gumbel, GEV, and TCEV, also with the reference value for the shape parameters, on the basis of the sample size and skewness. Another important aspect is the possibility of used Gumbel maximum likelihood estimates also for GEV and for the ordinary component of the TCEV, which allows for a reduction of the computational cost with respect to carry out a specific calibration procedure for each probability function. Furthermore, by simultaneously analyzing the sample skewness of several time series, a user can obtain a quick indication about potential clusters in homogeneous regions. In conclusion, concerning future developments for the software, specific modules will be implemented concerning modeling with a non-stationary approach, second and third level of statistical regionalization, and creating shape files suitable for spatial representation into GIS softwares. Thank you for your attention, and for a question, please send me an email. See you soon. Bye-bye.